Hey guys, welcome to Maths Academy Tube. Here I have a problem solving video lesson on rational function. I believe that after you watch this video, you can catch the full concept of the unit. So I need you to pay attention for my video. The first problem is, which of the following is the simplified form of the given rational expression. Here we have a certain rational expression. Therefore, here the question is the simplified form of this rational expression. That means 4 minus a minus 2 the whole square over a to the power of 4 plus 2a squared plus 1 divided by 1 minus 1 over a squared plus 1 the whole over a. So we can write this as 4 minus this thing in the bracket a minus 2 the whole square means a minus 2 the whole square means a square minus 4a plus 4 over here a to the power of 4 plus 2a square plus 1 means this expression can be shortly written as a square plus 1 the whole square divided by again we need to rewrite this this thing in other form so that it becomes a square plus 1 minus 1 over a square plus 1 the whole over a. So this can be written as 4 minus a squared plus 4a minus 4 over a squared plus 1 the whole square divided by a square here minus 1 1 with minus 1 is 0, so it becomes a square a times a square plus 1. We can multiply these two things. So we can take the reciprocal now. Here we have something that can be cancelled out. Positive 4 with negative 4, it can be cancelled out. So it remains minus a square plus 4a over a square plus 1 the whole square. Now we can take this is division, so taking the reciprocal, the operation will be changed into multiplication. Therefore, it becomes a times a square plus 1 over a square. Now we have something that can be cancelled out. A by a, this a square can be simplified, and a square plus 1 can also be cancelled out here, so that the remaining things becomes minus a square plus 4 over a square plus 1 times a. Here there is a for a, so again we can factor out a. If we take out a, then inside it remains minus a plus 4 over a square plus 1 times a. Now a by a, the remaining things becomes minus a plus 4, or you can make it 4 minus a over a square plus 1. This is the last simplified form for the given rational expression. Therefore, our answer will be D. Which of the following function has no vertical asymptotes? For example, the first function, the function in A, f of x is equals to logarithm of x plus 1 in base A. Ln of x plus 1 in base A means logarithm of x plus 1. Ln of x plus 1 means logarithm of x plus 1 in base E. Obviously, this logarithm is defined for x plus 1 positive. That means x plus 1 should be always greater than 0. So x must be greater than minus 1. It can't touch x is equals to minus 1. Therefore, for this logarithmic function, x is equals to minus 1 is a vertical asymptote. So the first function has a vertical asymptote. Let's check for the case in B. This is A. When we see the case in B, that means when we consider f of x is equals to x squared minus 9 over x minus 3, this can be written as x minus 3 times x plus 3 over x minus 3. Therefore, this can be cancelled out, but x should be different from both positive 3 and negative 3. At both x3 and minus 3, the function is undefined, but the simplified form of this function is x plus 3. Okay, our function f of x is x plus 3. At x is equals to 3, the function has a hole. So there is no vertical asymptote for the function in B. So this has no vertical asymptotes. So you can check that the remaining two functions, the function in C and D, will have a vertical asymptotes. For example, a function in C, f of x is x squared plus 1 over x cubed plus 8. Here, x cubed plus 8 can be factored out as x plus 2 times x squared minus 2x plus 4, as you can check. So this function has a vertical asymptote at x is equals to minus 2. So the function in C has a vertical asymptote. Let's check for the function in D. F of x is equals to x minus 1 over x squared minus x is equivalent to x minus 1 over x times x minus 1. So this can be simplified into 1 over x, which has a vertical asymptote, at x is equals to 0, and it has a hole. At x is equals to 1. Okay, because here x minus 1 is cancelled out. So at x is equals to 1, it has a hole. So this function has also a vertical asymptote. So the question is, which one of the given function has no vertical asymptote? So the answer is B. What is the solution set of a rational function given here? So usually when we find the solution for a rational function, we first put the domain or the restriction on x. The given rational equation is 2 over x minus 2 over x squared minus 2x is equals to 1 minus 2x minus 2 over 3x minus 2. This is the equation. So this rational function will be undefined whenever x is 0 and whenever x is 2, and the other thing whenever x is 2 over 3. The things that I am encircling here will be 0 whenever x is 0, 2, and 2 over 3. Therefore, the domain for this or the restriction on x is every real number can be considered except 0 2, and 2 over 3. So x cannot be these numbers, 0, 2, 2 over 3. So let us proceed. The equation is 2 over x minus 2 over, we can factor out x squared here, x squared minus 2x as x into x minus 2, which is equals to 1 minus 2x minus 2 over 3x minus 2. So taking the LCM, we can get x into x minus 2 in the denominator, then 2 into x minus 2 minus x minus 2 is equals to, here you can use crisscross or whatever you call it, LCM. So it becomes 3x minus 2 minus 2x minus 2 over 3x minus 2. So this can also be written as 2x minus 4 minus x plus 2 over x into x minus 2 is equals to 3x minus 2 minus 2x plus 2 over 3x minus 2. Okay, now let us collect like terms. 2x with minus x, it becomes x. Minus 4 with positive 2, it becomes minus 2 over x into x minus 2, which is the same as x here. 3x with minus 2x is x, minus 2 with positive 2 is 0, therefore it becomes x over 3x minus 2. Now here this x minus 2 can be cancelled out, then in the denominator it remains 1. So this is the same as 1 over x is equals to x over 3x minus 2. Now use crisscross. Okay, let me use this part. So using crisscross, it becomes 3x minus 2 is equals to x squared. This implies collecting all the terms in one side. It becomes x squared minus 3x plus 2 is equals to 0. This is quadratic, so you can use factorization or quadratic formula to solve this equation, but for me, I prefer to use factorization to save time. So the factorized form of the given quadratic becomes x minus 2 times x minus 1, which is the same as 0. So this is x minus 2 is equals to 0, or x minus 1 is equals to 0. From here, we can get x is 2 or x is 1, but here at the beginning we put some restrictions on x to keep the equation defined. So x cannot be 0, x cannot be 2, x cannot be 2 over 3. Here in our solution we have got x is 2. This cannot be a solution, we have to discard from the solution. So the only solution that we have is x is equals to 1. Therefore the solution set for the given rational equation is 1. So you can check that 1 can satisfy the equation. So our answer will be D. Which one of the following is true? A polynomial can have infinitely many vertical asymptotes. This is a wrong statement, because a polynomial function is a function with no vertical asymptotes whose domain is all real number. So the statement in A is wrong. The graph of irrational function can never cross its horizontal asymptote. This is also wrong. For example, if you take the function f of x is equals to 2x over x squared minus 9, you can see that the graph will cross the horizontal asymptotes. Its horizontal asymptote for this function is y is equals to 0. It can cross. Okay, so there is the possibility to cross the horizontal asymptote, not for the vertical asymptotes. So the statement in B is wrong. Let's see for the third choice. The graph of f of x is equals to x cubed minus x over x squared minus x has no vertical asymptote. So let's check for the function in C. F of x is x cubed minus x over x squared minus x. Basically, this function is not defined at x is equals to 0 and at x is equals to 1. X cannot be 0, x cannot be 1. So let us check what the function looks like by simplifying. So x cubed minus x means x into x squared minus 1 over x squared minus x means x into x minus 1. So we have something that can be cancelled out. Then it remains x squared minus 1, x squared minus 1 over x minus 1. Again, x squared minus 1 can be written as x minus 1 times x plus 1. Now we have another term that can be, another expression that can be cancelled out. So the simplified form of the given function is x plus 1, which is a straight line, but for this straight line you will have a hole. There will be a hole at x is equals to 0 and 1 because x cannot be 0, x cannot be 1 in this function. So this function has no vertical asymptote. It has no vertical asymptote. Okay, so the statement in C is a correct statement. So definitely our answer will be C. Let's check for D. In D we have a function f of x which is 3x minus 1 over x minus 1. This has no horizontal asymptote. It has a horizontal asymptote. So the horizontal asymptote for this function is the horizontal asymptote for this function is y is equals to 3. If you want to know how you can get the horizontal asymptote, just evaluate the limit of the function f of x as x approaches to infinity. So you can get that the limit of 3x minus 1 over x minus 1 as x approaches to infinity is 3. This means the horizontal asymptote for the given function. So we use the limit at infinity to calculate the horizontal asymptote, and we use the solution for the denominator to determine the vertical asymptotes. So for this question, the answer is C. Which of the following is true about the function x squared minus 1 over x minus x squared? So let us write the function in its simplified form. First, we need to put the restriction on x that makes the function undefined. The function is x squared minus 1 over x minus x squared. So this function is not defined at x is equals to 0 and 1. So this is our restriction, or the domain. The domain of this function is all real number. The domain of f is all real number except 0 and 1. So let us write the function itself in its simplified form. So the function x squared minus 1 means x minus 1 times x plus 1 over x minus x squared means you can take out minus x from the bracket, then it becomes x minus 1. You can check that this is exactly the function itself. Now we do have something that can be cancelled out so that the function f becomes the negative of x plus 1 over x. Okay, so this is our function in its simplified form. Obviously, the function will have a hole the function will have a hole in which x minus 1 becomes 0. That means at x is equals to 1, f has a hole. Then solving this thing for 0, at x is equals to 0, f has a vertical asymptote, and the horizontal asymptote is y is equals to minus 1 is a horizontal asymptote for the graph, because the horizontal asymptote is the ratio of the coefficients of the highest degree in the denominator in the numerator over the denominator, 1 over minus 1, which is minus 1 itself. Now let us see the choices. X is equals to 0 and x is equals to 1 are vertical asymptote. This is wrong. The only vertical asymptote is x is equals to 0. Okay, this is the only vertical asymptote. At x is equals to 1, it has a hole, not vertical asymptote. Y is equals to 1 is a horizontal asymptote. This is also wrong. Y is equals to minus 1 is the horizontal asymptote. Y is equals to x minus 1 is oblique asymptote. There is no more oblique asymptote for this function. The oblique asymptote exists whenever the degree of the numerator is greater than the degree of the denominator. So the first three choices are wrong. Let's check for D. It is almost the same as the horizontal line y is equals to minus 1 as x approaches to plus or minus infinity. So this is a true statement. So the answer is D. How it becomes true? It says the function, or I mean the horizontal asymptote is y minus 1. Y is equals to minus 1. This is obtained whenever the limit of a function as x approaches to positive infinity or the limit of f of x as x approaches to negative infinity. In any of the extreme cases, the value of the function, I mean the limit of the function, will be minus 1, which is assumed to be the horizontal asymptote. Therefore, the statement in D is a correct statement about this function. If P of x is 3x squared and Q of x is x squared plus x, then what is the solution set for the given rational equation? So the equation, or the question is, what is the solution set for P of x over 3 times Q of x minus 1 over x, which is 1 over Q of x? So as usual, we need to put a restriction for this equation. So that restriction is the point in which the equation becomes undefined. So x cannot be 0, x cannot be 0 here. Q of x cannot be 0. That means Q of x cannot be 0 and minus 1. So this restriction should be here before proceeding to the solution process. So let us put the given information in place of P. Use 3x squared over 3 times in place of Q. Q is x squared plus x minus 1 over x is equals to 1 over Q of x. In place of Q of x, again put x squared plus x. Now this can be written as 3x squared over, you can take out the common here, 3x into x plus 1 minus 1 over x is equals to 1 over x into x plus 1. So now you can cancel 3. In fact, you can also cancel one more x variable from here. But for the sake of simplicity, I want to put x times x plus 1 in the denominator. So x into x plus 1, then here it becomes x squared minus x plus 1, which is equals to 1 over x into x plus 1. You can use LCM. In short, I'm using here LCM. So this becomes x squared minus x minus 1 over x into x plus 1, which is the same as 1 over x times x plus 1. Now you can multiply both sides by x times x plus 1. Okay, multiply both sides by x times x plus 1. Then the things in the denominator can be eliminated. So the things that remains will be x squared minus x minus 1 is equals to 1, which is the same as x squared minus x minus 2 is equals to 0, collecting like terms. So now the only thing that remains here is solving this quadratic. So you can use whatever technique that you like. Here I prefer to use factorization. The factorized form of this quadratic is x minus 2 times x plus 1 is equals to 0. So this becomes x minus 2 is equals to 0, or x plus 1 is equals to 0. This implies x is 2 or x is minus 1. But minus 1 is in our restriction. We cannot take x is equals to minus 1 because the equation will be undefined at minus 1. So the only number that we can take as a solution is x is equals to 2. Therefore, our solution set will be a set containing 2. So our answer will be 2. The value of x where the graph of the function y is equals to x squared minus 1 over x cubed crosses its horizontal asymptote is, or are, what are the point of intersection of the horizontal asymptote and the given graph. So shortly, that is the question, or we are asking the point in which the horizontal asymptote and the given function intersects. Basically, the function y is equals to x squared minus 1 over x cubed has a horizontal asymptote. Its horizontal asymptote is y is equals to 0, because the function, if you see the function, the degree of the denominator, the degree of the numerator is 2, the degree of the denominator is 3. Since the degree of the denominator is greater than the degree of the numerator, the horizontal asymptote will be 0. This is what you need to know about the horizontal asymptote for a rational function. So y is equals to 0 is the horizontal asymptote. We are asked the intersection, or the point in which the function and the horizontal asymptote intersects. So we need to make this y 0. 0 is equals to x squared minus 1 over x cubed. So you can use crisscross. So 0 times x cubed is 0 is equals to x squared minus 1. So x squared becomes 1. This means x is plus or minus 1. So the horizontal asymptotes and the function will intersect at both 1 and minus 1. So our answer will be A. Which of the following function could most likely be drawn as in the figure below? So there is a figure here that you can see on the screen. So which of the given function can can properly describe the given function. So let's check the property of each functions in the choice. For example, in A, the function in A, f of x is equals to x plus 3 over x plus 2. This function has a vertical asymptote. The vertical asymptote for this function is x is equals to minus 2, or you can solve the denominator for 0. That will be the vertical asymptote. And the horizontal asymptote for this function is take the ratio of the leading coefficient on the denominator and the numerator. The horizontal asymptote is y is equals to 1. Here the graph has a horizontal asymptote y is equals to 1. This is x is equals to minus 2 is a vertical asymptote. But the given function has a hole at x is equals to 2, but the given function in A, this will not have a hole. So A cannot properly describe the given function. So let's check for the function in B. F of x is equals to x squared minus 2x over x squared minus 4. We have to rewrite this thing as x into x minus 2 over x minus 2 times x plus 2. You see this function will have this form x over x plus 2. So since we cancelled x minus 2, x is equals to 2 is, at x is equals to 2, there is a hole. There is a hole. X is equals to 2 is a hole for the function. And the other thing, when you solve this thing for the row, the vertical asymptote is x is equals to minus 2. Still it looks something. There is a hole here. And the other thing, divide the coefficient of the leading coefficient for numerator and the denominator at y is equals to 1 is the horizontal asymptote. Still it looks like describing the function, but the function in B, this fails because this function is a function passing through the origin. That means both x and y will be 0. That means it passes through the function. So, but this function, the graph, is not a function passing through the origin. But the rest are similar. So it fails only that condition. Therefore, we don't expect the function in B to satisfy the given graph. Let's see the case in C. The case in C immediately will fail because the horizontal asymptotes for the given function f of x is equals to minus x squared minus x plus 6 over x squared minus 1 is the horizontal asymptote is y is equals to minus 1. Divide the coefficient of the numerator and the denominator, the degree of the numerator and the degree of the denominator. Therefore, here the horizontal asymptote is y is equals to 1. Therefore, we don't expect the function in C to describe this graph. The only thing that is left here is the function in D. So let's check the function in D. F of x is equals to x squared plus x minus 6 over x squared minus 4. So this can be written as x plus 2 times, x plus 3 times x minus 2 over x plus 2 times x minus 2. So obviously this will be cancelled out. So at x is equals to 2, we expect a hole. A hole is obtained at the expressions where it is cancelled out. So at x is equals to 2, there is a hole. There is a hole for this function. The other thing, the function is simplified into x plus 3 over x plus 2. Obviously, at x is equals to minus 2, solving this for 0. at x is equals to -2, you will have a vertical asymptote, and the horizontal asymptote is y is equals to 1, dividing the coefficient of the leading term in the numerator and the denominator. So this function can properly describe the given graph. Therefore, our answer will be D. Suppose f of x is q of x. F of x is described in terms of q of x over x times x squared minus 1, where q of x is any quadratic function. So which of the following is necessarily true about the graph of the function? So we need to be very careful to answer such kind of problems. For example, q of x can be any quadratic function. So let's check the statement in A. In A, it says 0, 1, and -1 are the vertical asymptotes of the graph. This is not necessarily true, because if I take q of x as something like this, if q of x is x squared, you see the function f of x will be x squared over x times x squared minus 1. This can also be simplified as x over x squared minus 1. For this function will have a vertical asymptote at 1 and -1 only. So A is not true. Let's check for the statement in B. The graph of f does not intersect with its horizontal asymptote. Still, this is also false. Just take only this case, okay? You can take only f of x, I mean q of x is equals to x squared. That means the function f of x becomes x over x squared minus 1. So this function will crosses the horizontal asymptote at x is equals to 0. Therefore, does not intersect. This is wrong. Let's see the statement in C. The vertical asymptotes of the graph of f is only -1 if q of x is x squared minus 1. I mean x squared minus x. Let's check. F of x is q of x, which is x squared minus x. According to the given information here, q of x is x squared minus x over x into x squared minus 1. So we can factor the denominator, I mean the numerator. So it becomes x into x minus 1 over x into x squared minus 1 is also x minus 1 times x plus 1. Now we do have something that can be cancelled out. So here the function is simplified into 1 over x plus 1. Definitely this function will have a vertical asymptote at x is equals to -1 only. The rest at 1 and 0, it is a whole. Therefore, the statement in C is necessarily true. It's okay. The D case, the vertical asymptotes of the graph of f is only x is equals to 1 if q of x is 2x squared. Let's check it. So in place of q of x, substitute 2x squared over x into x squared minus 1. Now this can be simplified to 2x over x into, 2x over x squared minus 1, which is 2x over x minus 1 times x plus 1. Therefore, this function will have a vertical asymptote at x is equals to 1 and at x is equals to -1. So it's not only x is equals to 1. So this statement is not necessarily true. So our answer for this problem is C. Which one of the following is true about the horizontal asymptote of the graph of y is equals to absolute value of x plus 2 over x? So the function is y is equals to absolute value of x plus 2 over x. So we are asked about the true statement about the horizontal asymptotes of the given function. Normally, the function is y is equals to absolute value of x plus 2 over x. So absolute value of x is plus or minus x, depending on the value of x. So we can write this function as y is equals to x plus 2 over x, or this is for x greater than 0, or y is equals to minus x plus 2 over x for x negative. So here the horizontal asymptote is the value of the ratio of the leading coefficient. The horizontal asymptote is the value of the ratio of the leading term in the numerator and in the denominator. Therefore, the horizontal asymptote for this function will be y is equals to, take the ratio of here 1 over 1, which is 1, or y is equals to minus 1 over 1, which is minus 1. So there are two horizontal asymptotes for this function. So y is equals to 1 and y is equals to minus 1 are the horizontal asymptotes for this function. Which one of the following is true about the graph of f of x is equals to x cubed minus x over x cubed into x minus 1? So let us write the function in its simplified form first. F of x is x cubed minus x over x cubed into x minus 1. So let us factor out everything, then x into x squared minus 1 over x cubed into x minus 1. Again, this can also be written as x into x minus 1 times x plus 1 over x cubed into x minus 1. So for this function, x cannot be 0 and x cannot be 1. So this is our restriction on x. So, but the simplified form of this function, you can cancel out x minus 1 and x. So the given function becomes x plus 1 over x squared. So this is our function with the restriction x different from 0 and x different from 1. Now let's go to the choices. The vertical asymptote of the graph are 0 and 1. The vertical asymptote is only at x is equals to 0, therefore the statement in A is wrong. The horizontal asymptote of the graph is y is equals to 1. The horizontal asymptote is y is equals to 0. So the horizontal asymptote is y is equals to 0. So the statement in B is wrong. Or you can calculate the limit of the given function x plus 1 over x squared as x approaches to infinity. This is 0, which is assumed to be the horizontal asymptote for the graph. The statement in C says the graph intersects its horizontal asymptote at x is equals to minus 1. So first of all, the graph has a horizontal asymptote which is 0. So at 0, the graph, for example, the horizontal asymptote is y is equals to 0. So the function becomes 0 whenever x plus 1 over x squared is 0. This implies x is equals to minus 1. So the horizontal asymptote crosses the function at minus 1 comma 0 is a true statement about the graph. The last statement, so we expect this to be the answer. The choice in D is the graph intersects the vertical line x is equals to 1 at the point 1 comma 2. This is wrong. In the case of rational function, the vertical line or the vertical asymptote cannot be crossed. So here we have the restriction on x. X cannot be crossed because there is a hole at x is equals to 1. So what is the partial fraction decomposition of the given rational expression? So there is a rule for decomposition into partial fraction. Now our expression is x squared plus x plus 1 over x plus 2 into x squared plus 1. This is our rational expression. We decompose this rational expression into some constant over linear x plus 2 plus here this x plus 2 cannot be this x squared plus 1 cannot be factored into other linear form. So the rule says some linear over the expression should be here. Okay, this is the first step in decomposing the given rational expression. Then the rest will be very simple. You can use LCM or whatever you like. You can use crisscross. So the given expression becomes a into x squared plus 1 times, plus bx plus c into x plus 2 over x plus 2 times x squared plus 1. Okay, this is the second step. Now you can use distribution. You have to distribute this a into the bracket, and we need to multiply these linears. So let us do that calculation, that simple calculation. So ax squared plus a plus bx squared plus 2bx plus cx plus 2c over x plus 2 times x squared plus 1. Again, you can rewrite this thing as by collecting like terms. Okay, you can collect like terms and factor out. Then it becomes a plus b into a plus b times x squared plus, again, collect like terms here, this one, 2bx with cx, then it becomes 2b plus c, then x is common for both. The other thing, a variable free numbers a and 2c, then a plus 2c over x plus 2 times x squared plus 1. Now we are comparing these two things, x squared plus x plus 1 over x plus 2 times x squared plus 1 is the same as, according to this notation, this is the same as a plus b into x squared plus 2b plus c x plus a plus 2c over x plus 2 times x squared plus 1. Now these two rational expressions are the same. Obviously they have the same denominator, so we need to compare their numerator. We are assuming that these two expressions are the same. So the coefficient of x squared here is 1. The coefficient of x squared is a plus b. So this a plus b must be 1. Okay, this must be 1. and the coefficient of x here is 2b plus c. The coefficient of x here is 1, so 2b plus c must be 1 again, and the constant term here is positive 1, and the constant term here is a plus 2c, so a plus 2c is 1. So we need to solve this simultaneous equations of 3 variables with 3 equations. So you can take call this is the first equation, say this is the second equation, and this is the third. If you take the difference between the first and the third, taking the difference between the first and the third, you can get b minus 2c is equals to 0. Take the difference between the first and the third, you will get this equation. Okay, call it equation 4. Again, take here we avoided the variable a, so you can also take the second equation. From the second equation already we have 2b plus c is equals to 1. You see, now we have reduced the 3 variables into 2 variables. Now multiply the first equation by 1, the second by 2, then this becomes b minus 2c is equals to 0, and 4b plus 2c is equals to 2. You can multiply everything, the second equation by 2. Now add them, it becomes 5b is equals to 2. This implies b is already 2 over 5. Dividing both sides by 5, b is 2 over 5. Look, if b is 2 over 5, here b is 2 over 5. Okay, you can so here we have 2 over 5. So in place of b here, you can substitute the b value to get the value of a. So a plus 2 over 5 is equals to 1, implies a is equals to 1 minus 2 over 5, which is 3 over 5. So the value of a is 3 over 5. Okay, here the value of a is 3 over 5. So you can use the third equation to get the value of c. So substitute in the third equation, 3 over 5 plus 2c is equals to 1. This implies our 2c must be 2 over 5, which is c is equals to 1 over 5. Therefore the decomposition of this rational expression will be a over x plus 2, which is a is already 3 over 5 into x plus 2, plus b is 2 over 5, c is 1 over 5, so you can use it here. So it becomes 2x plus 1 over, you can take it 5 down, then this becomes x squared plus 1. So the decomposition of the given rational expression will be the choice in A. So which of the following is true about the graph of f of x is equals to 2x cubed plus 2x squared plus 3x over x squared plus x? So let us put the function first in its simplified form. That is very helpful for us to understand the function. So the function is 2x cubed plus 2x squared plus 3x over x squared plus x. This is our function. So its simplified form is, x into 2x squared plus 2x plus 3 over x into x plus 1. So we need to put a restriction. This function, for this function, x cannot be 0, x cannot be minus 1. Because when you solve the denominator for 0, you can get 0 and minus 1. We need to put a restriction on this function. So the simplified form will be 2x squared plus 2x plus 3 over x plus 1. This is the simplified form. So let us see the statement. We are asked the true statement about this function. The vertical asymptote of the graphs are 0 and minus 1. That is wrong. 0 is not a vertical asymptote. Rather, at x is equals to 0, there will be a hole. So the statement in A is wrong. The graph has y-intercept at 0, 3. The function will not have a y-intercept at 0, 3 because x cannot be 0, so it will not have a y-intercept. So without knowing the graph, you can immediately sense the statement in B is wrong. The C case, the graph has at least one x-intercept. Let us see. This is our function. F of x is equals to 2x squared plus 2x plus 3 over x plus 1 for x different from 0 and minus 1. This is our function. So this graph has at least one intercept, means the x-intercept will be obtained by making y 0. So make this 0. So the things becomes 2x squared plus 2x plus 3 is equals to 0. So whenever you solve this quadratic, there is no solution. That means there is no more x-intercepts. So the statement here is wrong. It's wrong. Again, let's check for D. By default, we expect the answer to be D, but let's check it. The vertical asymptotes of the graph is only x is equals to minus 1. Yes, indeed. X is equals to minus 1 is the only vertical asymptotes, and its oblique asymptote is y is equals to 2x. The oblique asymptote is an asymptote which is obtained by dividing the numerator by the denominator. So when you divide 2x squared plus 2x plus 3 for x plus 1, you can use polynomial division. You will get the oblique asymptote. So 2x squared by x is 2x. 2x times x is 2x squared. 2x times 1 is 2x. Then takes the difference. The remainder is 3. Therefore, 2x is also the oblique asymptote. So obviously the statement in D is true about this function. Which of the following is true about the graph of f of x is equals to this thing? So let's see what the graph will looks like. Basically the function is x squared plus 5x plus 6 over x squared minus 4. There is plus 3. So we need to put a restriction for this function. X cannot be 2 and minus 2, because at these two values the function will be undefined. But let us put this function in its simplest form. Then x squared plus 5x plus 6 means x plus 2 times x plus 3 over x squared minus 4 means x plus 2 times x minus 2. There is plus 3. Now we can have something that can be cancelled out. X plus 2 is cancelled out. Then x plus 2 is cancelled out, means at x is equals to minus 2, there will be a hole. There will be a hole for the graph of the function. So the simplest form for the given function is x plus 3 over x minus 2. There is plus 3 here. Then the graph has a hole at x is equals to 2. This is wrong. It has a hole at x is equals to minus 2. The vertical asymptotes of the graph are 2 and minus 2. No, the vertical asymptote is obtained at this expression. X minus 2 is equals to 0 means x is equals to 2 only is the vertical asymptote. So the statement in B is also wrong. The horizontal asymptotes of the graph is y is equals to 4. Yes, this statement is true because as you know, the horizontal asymptotes for the given function will be obtained by calculating the limit at infinity. That means the limit of the function or the expression x squared plus 5x plus 6 over x squared minus 4 plus 3 as 6 approaches to infinity is 4. This is the horizontal asymptote for our graph. So the C case is a true statement. Let's check for D. D should be false. The graph has y-intercept at x at 0, 3 over 2. The y-intercept is obtained at x is equals to 0. So make x is equals to 0 here. This thing will be eliminated. Then the remaining things will be 6 over minus 4 plus 3, which is minus 3 over 2 plus 3, or this is 3 over 2. So the x-intercept is 0, positive 3 over 2, not negative 3. So due to this negative, the statement in D is false. So definitely our answer for this problem is C.